So angle of repose means it is the angle made by the inclined surface with the horizontal at which the object starts sliding by overcoming the frictional force. Okay. So this is the definition which we saw. There is another term called as angle of friction. So write down this one. So angle of friction is represented by the symbol lambda. So angle of friction means, write it down, it is the angle between the frictional force it is the angle between the normal force and the resultant of frictional force and normal force. Okay, I'm repeating it. It is the angle between the normal force and the resultant of frictional force and normal force. Let us see what is the meaning of it. Let us say you have a surface like this, a rough surface on which there is a block that is placed of mass m. Okay. Let's say you're trying to pull the block capital F, then the frictional force will act to the right. Then the normal force will be like this, and this is the direction of frictional force. I hope you are able to visualize this. So this is the frictional force, this is the normal force. So how will the resultant of normal force and the frictional force be? When I say resultant, when you apply parallelogram law of vectors, how will the angle between the normal force and the frictional force be? It will be somewhere like this, right? I'm calling this as resultant. I'm calling it as R. R means don't get confused with reaction force. So is it clear till this step?
Yes, sir.
Yes. So what is the definition saying? It is the angle between which force? The frictional force. So angle between the normal force. Okay, this is an important point. It is the angle between the normal force and the resultant of the normal and the frictional force. So if you take, then this is the angle they are trying to speak about, lambda. Okay. If you write this as lambda, then R vector can be written as F I cap plus N J cap. Okay. R vector is equal to F I cap plus N J cap. Now, see, I've already told you this thing. If A vector is equal to X I cap plus Y J cap, then we know that tan theta is equal to Y by X, where theta is the angle made with respect to X axis.
Yes.
I hope you. Yes. So here what will happen is, okay, 1 minute. Yes, tan theta is equal to, okay, I'll not go in this way. I'll explain it in a different way. Observe. Okay, these two vectors, okay. Let's say the resultant is like this. This is X and this is Y. If you take this as theta, then tan theta is always written as Y divided by X, where theta should be with respect to what? With respect to X axis. So what I'm trying to tell here is, if you take this as theta, with respect to theta, what is the opposite? So with respect to is Y. With respect to theta, the adjacent is X. So we know that tan theta is equal to opposite by adjacent. That is why we wrote it as Y by X. In a similar way, if you look at the angle here, if you take this as lambda, Okay, 1 minute. I'm erasing this step. If you take this as lambda, then can I write tan lambda is equal to what? So with respect to lambda, what is the opposite?
Friction.
Friction divided by the adjacent is
Normal.
normal. So, but friction is nothing but mu s into n, and normal is normal only. N and n will get cancelled. Answer will be mu s. So tan lambda is mu s. Yesterday we saw something else. Tan alpha is also mu s. Means in terms of definition, angle of repose and angle of friction are not the same. And in terms of significance also, they both are same. They both are different. They both are not the same. Okay. But mathematically, if you see, they both have the same value. Are you guys able to understand? So mathematically, yes, angle of friction and angle of repose are the same. In terms of significance, are they the same? The answer is no. Because angle of repose is applicable in different scenario, angle of friction is applicable in a different scenario. I will explain how they are applicable and when to use what. But tell me, are you guys clear with the definition part and the small derivation that we did? Is it clear or not?
Yes, sir.
Okay. So write it down. Okay. Now see, I'm going to show you how to visualize them. Then you will understand when to apply what. So I hope you are able to see me, right?
Yes, sir.
So I just got two random things in my hand. Observe. See, let's say I have a mobile phone. Let's say this is the surface and I have some balm in my hand. Now I'm placing this balm on this surface. So if I ask you a question, are they balanced or are they moving?
We are balanced.
They are balanced, right? Now, see, actually, I think I took two wrong objects, but okay. But try to visualize. So how is the plane actually? The surface, it is horizontal, right? On this horizontal surface, we have placed a mass.
Yes.
Correct? So we have placed a mass. Now, what will happen when I try to tilt this object? You're able to see that the bomb is moving. So it is moving, right? So when I try to tilt it, see, these are the two objects I got randomly. So when I try to tilt it, each object, depending, because the surface is smooth, it is starting to move fast because it is not able to offer enough friction. So when I try to tilt it, there will be one particular position after which the object will start sliding. Till that, if you see, the object will be at rest only. You can do this activity using a cardboard because cardboard can offer more friction. So you take a cardboard, the one which you would have got ordered in Amazon or something. You would be having a cardboard, right? On that, try to place some object. When you try to bend it like this, you do it slowly. When you do it slowly, you can see after one particular inclination only, the object will start sliding. Till then, it will not move at all. Okay. So where is the angle being made? This plane is making an angle with my hand. You're able to see this. I'm showing with my thumb.
Yes, sir.
So So this angle is there, right? So this is the angle where this plane is making with the horizontal, where the object just starts to slide is what is called as angle of repose. So angle of repose means what? It is the angle of the inclination at which the object starts to slide. Till then it will be at rest. Means it is experiencing static friction. So if the object is moving in this direction, static friction will be in this direction. I hope that point is clear.
Yes, sir.
Right. So when will you apply angle of repose? Angle of repose is applicable only for inclined plane. That is why if you read the definition, it will be very clear. Whereas angle of friction can be applied for a horizontal surface also. So if you take a horizontal surface, again I'm taking this bar. Okay, if I'm trying to push this object, I'm trying to apply a pushing force. The friction will act in this direction. So I'm trying to push in this direction. Friction along the surface will act in the rightward direction. So this is the friction. This is the normal force. This one is mg, right? Friction, normal, mg. So this friction and normal, there is going to be a resultant. If I take this as a resultant, the angle made by the resultant with whom? With the normal is what is called as angle of friction. So angle of friction can be applied either to a horizontal surface or inclined surface, but angle of repose is strictly applicable only to inclined surface. Are you guys able to understand this point? Am I clear?
I can do
Yes.
it. The video was paused for me, sir. Then I exited, sir.
You can actually have a look after the session. I'll upload the video. No?
Okay, sir.
Again, it will be
Sir, I
difficult
have
for me.
a doubt.
Yeah, tell me.
So in an inclined plane, can we say that angle of friction will be equal to angle of repose in an
Yes.
inclined
Yes,
plane?
yes. On an inclined plane, they both are same.
Oh,
But again, see, mathematically, they both are same. But I hope you understand the difference in significance. Significantly means if you talk in terms of application, angle of repose will come into play only when you try to tilt a plane with respect to the horizontal. Whereas angle of friction doesn't need any tilting. You can do it on horizontal. When you're able to do on horizontal, yes, you can do on inclined also. If you want to do on inclined plane, then what will happen is, on an inclined plane, the object is like this. Okay. So this object will try to move like this. This has mass m. Mg sine alpha. Alpha theta is this thing. Okay, this theta. Visualize it. So this is angle theta. This is mg sine theta. This side is mg cos theta. This is normal. And this side is friction. Okay. Friction in this direction. Normal in this direction. How will the resultant be? It will be somewhat like this.
okay.
So it will be something like this. So this is the resultant. This is the normal. This angle is what is called as the angle of friction. Okay.
Okay,
So
sir.
to define the angle of friction, you need to always take the resultant of whom?
Normal force and friction.
Normal force and frictional force. Whereas for angle of repose, you need to calculate only the inclination at which it starts sliding.
Okay.
Okay. Okay. So if you ask me what is the significance of both are used to calculate the coefficient of friction because it is an easy experiment to calculate. See, if I want to do an experiment, if I want to calculate what is the coefficient of friction of this surface, okay, I'm taking this surface. What I can do a simple activity. I can measure the mass of this. If I read it somewhere, it will be there. I'm not sure if mass is given. Let me check. No mass is given. Okay. Let's say it is m grams. So I will get mg sine theta in this direction.
Yes, sir.
I will get mu mg cos theta in this direction. So there are two things that I can calculate. So if you observe what is the expression, can you look at it and tell me what is the coefficient of friction in terms of angle of repose?
Mu is.
Mu.
Mu is equal to tan alpha. Yes, mu is equal
Tan
to tan
alpha.
alpha. Tan alpha. So for you to calculate static friction, what is the only parameter you need? You need the angle, right? So it is very easy for me. I'm not even going to calculate the mass of this object. That is also not needed. So when I'm going to tilt this, I'm going to observe what is the angle at which it is going to start sliding. I'll take a protractor, keep it here, and measure the angle. I'll just take the tan of that angle, that will give me the answer.
Understood, sir.
Okay, so that is a practical application. So these are the two important points. See, these are very simple concepts, but you need to have a clear observation of what it exactly means. Okay. So shall I move on to the next concept? That is banking of roads. That is the last point in this chapter. So just a minute. Just be on the line. I'm getting the textbook. Okay. So in laws of motion, we have completed everything. We have seen what is conservation of momentum, equilibrium of a particle, common forces. We have seen what is friction, static friction. Then there are few problems which are given on angle of repose and all those things. You can actually calculate and solve that. So rolling friction, they have just given you the theory part. Okay. So the last part that is left out in this chapter is circular motion. That is, we are going to see how friction is going to support objects which are in circular motion, especially when a car is trying to take a turn on road. Yeah.
I have doubt, sir. Sir, which is greater, angle of repose or angle of friction, sir?
Nothing. They both are mathematically same.
Significantly, sir.
They both are different. That's what I told. No, angle of friction can be applied for horizontal and inclined plane, but angle of repose is applicable only for inclined plane.
Okay, sir.
Yeah. So you're able to understand. So the last part of this chapter is circular motion. So you can ask me, we have already learned the circular motion in the previous chapter. Then what is the difference between that one and this one? So there, what did we discuss?
Tangent.
Now, here also we will discuss all those things, tangent and all. So in the fourth chapter, the circular motion which we studied was uniform circular motion. Okay, when you talk about uniform circular motion, the object is going to experience only which acceleration?
Uniform.
Wrong. Okay, sorry?
Constant.
Centripetal accelerations.
It will experience centripetal acceleration. So when an object is in a circular motion, okay, so when an object is in circular motion, there are two accelerations that are possible: centripetal and tangential. Okay, but if the object is in uniform circular motion, it experiences only centripetal acceleration, and the tangential acceleration is not going to exist. Okay, similarly, make a note of it. So the point I'm going to tell you is applicable even for other concepts in 12th standard also. Not only 12th standard, throughout your life, wherever this has to happen, this physics should be there. So write the point: for any object to be in circular motion, for any object to be in circular motion, comma, centripetal acceleration is necessary. Centripetal acceleration is necessary. Then what you can write is centripetal tangential. Put it like this. uniform circular motion, prepare a table like this, okay? Then non-uniform circular motion. So for uniform circular motion, centripetal acceleration will be there or not?
It will be there, sir.
It will be there,
Yes,
but tangential will not be there.
Okay.
Whereas for non-uniform circular motion, centripetal is there and tangential is there. Tangential means along the tangent. Centripetal means along the radius. So the other name for centripetal is radial also. Okay. Are you clear with this? So in both the cases, the compulsory factor is centripetal. So going forward, wherever you see circular motion, because this concept gets repeated in next chapter also. Not only next chapter, the chapter next to it also, everywhere. Even in the 9th chapter, 8th chapter, it gets repeated. So everywhere you see circular motion, by default, centripetal acceleration should come to your mind. Then you should ask a question whether you're talking about uniform or non-uniform. If you're talking about uniform, then tangential will be absent. If you're talking about non-uniform, this tangential will be present. Okay. Now what we are going to see is, we are going to see the applications of friction. Actually, the topic is given as circular motion. Circular motion of what? It is a circular motion of a car which is trying to take a curve, which is trying to take a turn, on two kinds of surfaces. One is on a rough surface, one is on a level rough surface, and the second is a inclined rough surface. So that is why, if you look at the topic here, I hope you guys are able to see this. Circular motion of a car, I am highlighting it. See, circular motion of a car on a level road and a road which is inclined, which is called as banked road. Tell me one thing, are you guys clear till this point?
Yes,
Yes,
sir.
sir.
Okay. So again, I'm switching on my video because I have to show you something. Try to visualize it, okay? Don't memorize it. This is a very, very important question. This banking of roads concept. I've seen this question every year. See, tell me one thing. Along with this, if I share my screen, are you guys able to see both?
No, sir.
No, sir.
What are you able to see?
We are able to see only a screen.
Yes, share the screen, sir.
Only screen is visible. Okay. Okay. Because of the device. Okay. I'll do one thing. I'll swap between both. Okay. So first, I'm showing the screen. We'll get used to it. So the circular motion, as I told you, let me read this out. Okay. We have seen in chapter 4 that acceleration of an object moving in a circle of radius r with uniform speed v is v square by r, which is directed towards the center. We know this value, right? This is the value of the centripetal acceleration. We saw the derivation also. Then, if you apply second law, what does second law state? The second law states F is equal to m into a. What force it is, that we'll discuss later. So if the mass of the object is m and it is revolving in circular motion, then mass multiplied with the centripetal acceleration is going to give you what? See, mass multiplied with the acceleration.
Force.
It is called
Force.
centripetal. Okay, you need to be very careful with this. When I ask you centripetal acceleration, you should report the answer without mass. When I ask about centripetal force, you need to report it with mass. That is mass multiplied with v square by r. I hope you guys are able to understand this. It's a very minute difference, but important thing. This is called as centripetal force. Suppose you take a stone and rotate it in a circle by a string. The centripetal force is provided by the string. Okay, that is what is given there. In a similar way, what we are going to see is, see, there are some applications given. The centripetal force for motion of a planet around the sun. So we know that the planets revolve around the sun. It is because of the gravitational pull that is existing between the sun and the planet, which is putting it in the circular motion. And that gravitational force is providing the necessary centripetal force for the particle to be in circular motion. So one thing I hope it is clear, for any object to be in circular motion, yes, centripetal acceleration should be present. If somebody tells you the object is in circular motion but it doesn't have centripetal acceleration, then it is completely wrong. Okay. Only thing is, the common formula for centripetal force is mv square by r. Whether you apply it in this chapter, next chapter, or in your PhD or whatever it is, the formula is fixed. mv square by r is the only formula for centripetal force. But the left-hand side keeps changing. That centripetal force should be provided by some real-time force. For example, when you tie a stone to a circle, who's providing the centripetal force? It is the tension in the string. Similarly, if the planet is revolving around the sun, it should also experience some centripetal force of the value mv square by r. But who's providing the necessary centripetal force there? It is the gravitational force on the planet. The gravitational force between the planet and the sun is what is providing the necessary centripetal force. Similarly, there is an electron which is revolving around the nucleus. Who's providing the necessary centripetal force?
Nucleus.
It is the electrostatic force between the nucleus and the electron, because there will be an attractive force, right? So that is providing the necessary centripetal force. So based on this only, now we are going to see a concept, that is motion of a car on a level road, and the next is the motion of a car on a banked road. These are the last concepts. Okay. So when a car is revolving on a level road, what exactly happens to it is what we are going to see. Okay. Now see. So if I take this as the car, okay, this as the road. Now visualize it. The car is going like this. Okay, it is going like this. And there is a turn that is going to be present here. Okay, so I want you to visualize it like this. This is how I'm drawing it. Okay, this is how the road is. Meaning, if this is my hand, the road is like this. I'll take a smaller object. So the road is like this. So there is a car which is going like this. When it is going like this, what is the direction in which it has the velocity? So this is the direction in which it has the velocity. Right? Yes. Whatever is the direction, right? Now, when it is moving in a straight line path, we have no issues. There is absolutely no issue. It is going on its own. Whether it is moving with constant speed or something, that's not our headache. Whereas, when it is trying to take a turn, okay, when it is trying to take a turn, the wheels of the car will be there now. So, observe, this is the road. The road is rough, means it has friction. So, the car is moving like this. By this hand, the right hand is the car. So, car is moving like this. When it is going to take a turn, when it is taking a turn, you are able to observe some relative motion. With the road is fixed. I'm not moving this, okay? You're able to see some relative motion of my hand. What is happening to my hand? You can do and see. You can do this activity and see what is happening. Car is going like this. You keep left hand fixed. Take your right hand, put it like this. Car is turning. When you see from the top, car is turning anti-clockwise. When there is an anti-clockwise turn that is taking place, okay? When there is an anti-clockwise turn taking place, the back part of the car is trying to move away from the center. Because when I say this is the circular path, when you see from the top, it will be like this. I hope you are able to visualize this part. Right? It is like this. When it is taking a turn like this, when the car is trying to move away, who will stop the car from getting drifted away? If the car is turning too fast, what would have happened? If the car is turning too fast, the car would have got skid and it will go like this. You would have seen certain things like this, right? Yes. There would have been an accident. The car will go like this and it will go and hit something. But what is happening when it is taking a safe turn? The car is turning like this. It's still on the road at the same point only. So when it is turning like this, who is actually supporting the motion of the car? Because we would have learned friction is an opposing force, right? But what exactly is happening here is, observe, when the car is turning this side due to the acceleration of the engine or whatever it is, the power caused by the engine, who is trying to keep the car in the circular path? What force will come? What force will be offered by the road on the car?
Tangents.
There will be a force that is acting in this direction.
Yes, sir.
What is the name of that? What force is supporting the car from getting skid?
Gravity.
It is a friction. Because when the tires are going like this, see, when will the car go and hit like this? When will the car get skid? Only when the
There's
friction,
nothing opposed.
only when the frictional force is not sufficient enough to stop it from getting drifted. But if the road has sufficient amount of friction, it is going to provide the enough amount of grip to the tires such that it is able to make a turn. Okay, so that is a point given in your book. Observe it. So whatever I explained, you're seeing from the top view. Okay, you're seeing from the top view. If you keep your mobile on the desk, then you're seeing from the top view. This is the center. And what is happening to the car? The car is trying to take a turn. Okay. So if the car has to safely turn along a circular path, for circular path, what is the necessary acceleration that should exist? V square by r, the centripetal acceleration should exist. If you multiply that V square by r with the mass of the car, that will give you the centripetal force. Okay. So when the car is trying to get drifted away like this, there is a frictional force that is coming into picture, which is providing the necessary centripetal force. So how to write the equation is, for this is motion of a car on level road. Okay. So friction or frictional force between whom?
The wheels of the car and the
Road and the tire, or you can say wheels of the car. Road and the tire is providing what? Necessary centripetal force for the car to take a safe turn. That is why if you go to the hill stations and see, they'll say the speed limit is this much when you take a car, because you will have many bends, right? So why they mention the speed limit is because that particular road can offer only grip of this much, grip of a particular value. If you try to go beyond that value, you cannot control, and something negative might happen. Okay. So how you are supposed to write the equation is, mathematically, F is friction is equal to mv square divided by r, where r is the radius of the circular track. Where r is the radius of the circular track on which the car is trying to rotate, or it is trying to take a circular turn. But what is friction? Friction is equal to mu mg on a level road. Friction is mu into n, but on a level road, n is equal to mg. So mu mg is equal to mv square by r. M and m will get cancelled. So mu into g is equal to v square by r, which implies v square is equal to mu rg. V is equal to root of mu rg. So this is the velocity with which the car is supposed to take a turn on a particular road, where you know the coefficient of friction of the particular road. There's a simple derivation, one small change. I'll write it as capital R because that is how they have given in the textbook. It is mu R into G. Accepted?
R resultant, sir.
Yeah, R is radius.
Okay, sir.
Radius of circular track. So write it down. Done?
1 minute, sir.
Okay.
Sir, can you show the
Yeah, 1 minute. Got closed. Sorry.
okay, sir.
Okay. So
Okay, sir.
this is all about level road. Where is it? So this is the motion of a car on a level road. What they are trying to say is the velocity should be less than or equal to this value. That is why it is called as maximum velocity. As I told you, it is a speed limit. Right? It is a speed with which the car can take a turn or a safe turn. Maximum speed of a circular motion of car possible. Okay. So I hope this point is clear. The next one is a slightly tricky. So this is motion of a car on a banked road. So let me explain what banking means. 1 minute, I'll be back. I'll get a book and come. Wait. Okay. Now listen. See, this is a road. Okay. This is a level road. So the meaning of banking is to take a safe turn on a particular road. What they would have done is at the edges, okay, at the edges of the road. If you can observe this in the mountainside and all, or hill stations and all, you can see the road would have got slightly bent like this. You're able to understand? That is, see, generally what will happen on a level road is, if say there is a car, when you're taking a turn, the car will have the tendency to get skid. It might go. Whereas if the road is slightly elevated in this way, then even if it is taking a turn like this, if it gets skid, it will go to the top and come back. You're able to visualize this part?
Yes, sir.
So that's what is called as banking of roads. So there is something called as angle of banking. Angle of banking means the angle that the road is making with the horizontal, so that there is a safe turn that is taking place. So it will be bent like this and it will be like this. So this angle is called as angle of banking. Means if this was a level road, if you make a slight bend on the outer edges, then this angle is called as banking of road. Now what we are going to do is, what should be the force for a road? What should be the force? Velocity of a car which is trying to travel on a banked road. That's what we are going to see. Okay. So when it was on a level road like this, what are all the forces acting on it?
I cannot see it clearly, sir.
What were the forces? You can visualize it. What were the forces acting on it? If it is a level road, what were the forces acting on it?
Friction and centrifugal.
So when it is going like this, friction was acting towards the center. Right? Friction was acting towards the center. Normal force was acting in upward direction. mg was acting in the downward direction. Okay. See, I'll do one thing then. Thing is, this topic you need to visualize. I'm not able to hold the camera properly. What I'll do is, in tomorrow's class, I will explain with an audio visual. Because there's an important concept which you need to visualize. I'm not able to explain it from here. Had it been a live class, I can actually show it. My camera is tilted. I'll try and wait. So when it is like this, okay, when the car is here, then what will be the forces that are acting on it?
Frictional force.
So it will still be free. So observe when it was horizontal, right? When it was on a level road like this, now it's better, no? Is it better now?
Yes, sir.
Okay. So when it was on a level road, what happened is when the car was trying to take a turn, the friction acted towards the center like this. When you see from the top view, it will be like this. The friction was acting towards the center. Whereas when it is banked like this, when it is bent in this way, what exactly will happen? The frictional force will still act, but the frictional force will not be like this, it will be in this way. So you have to hold it like this and the frictional force will act in this way. Means it will act along the inclination. Okay. So I don't think it is possible. This is not the right way to learn this concept. Okay. I'll try to arrange for some material aids in tomorrow's class, and tomorrow I'll teach this. The first 10 minutes will, first 10 to 15 minutes will start with this, then we'll go to the next chapter. Okay, this I'm not able to explain it from here. So what you can do for today is, you can revise it till here, and you can do the example problems based on this. I'll tell you certain problems, you can try them out. So you can try out example 5.10. Please make a note of it. Example 5.7, 5.8, 5.9. So 5.7, 5.8, 5.9. Then 5.10. Then exercise problems 5.5, 5.6, 5.7, So these are all the problems you can try. These are all very simple. You can try them out. In tomorrow's class, I'll complete this chapter. Okay. So is there any other doubt? Is there any other doubt from today's?
Doubt, not from today's class, something
Yeah,
you can do about tension, sir.
Yeah, tell me.
There was a question in this, I think 5.26, sir.
Okay.
Yes, sir,
This-
this highest point and lowest point.
Is
Sir,
tone
I had
of,
a,
yeah, tell me.
here I had a doubt in the highest point on how tension will act.
So a stone is tried and revolves in a vertical circle. So this is a vertical circle. So in the vertical circle, when it is revolving, there is going to be the center. If I take this as a center, the stone is here of mass m, then mg will act downwards and tension will be here.
The tension will be along the direction of the force, sir.
Yes, it should be. No? So here, both tension and mg both will try to pull the object towards the center. This is a concept you will learn in the next chapter. There is a concept itself. It's called as vertical circular motion. So
Okay, sir.
in this
Then,
case, how you write the equation is mg plus t will provide you the necessary centripetal force, mv square by r. So where is
Okay,
it?
sir.
Mg plus t1, where is it? Circle directed. So choose the correct alternative. Mg minus t1. What is t1 and t2? Denote the velocity and tension. So it should be mg. I have to read this question carefully. So this is how the force will be. Okay. Mg plus t will be
Okay,
equal.
sir.
Okay, that's it.
Thank you, sir.
Yeah. Any other doubt? That's it. No other doubts. So if no more doubts, we can wind up this session. So tomorrow's class, I'll explain banking of roads.